Welcome everyone. Just want to make sure if it's audible right till the end. Okay, awesome. Thank you. Welcome everyone. My name is Keyur Rajyaguru, and I'll just use this blank to introduce myself. I work with Walmart InfoSec. I work with their cyber defense operations. I work really closely with the intelligence, the detect engineers, and the devs as well at Walmart. And before working for Walmart InfoSec, I worked with a couple of years as a security consultant with Ernst& Young, designing security operation centers for some of their clients. And before that, I spent close to 2.5 years as a network engineer, working for a financial client or a bank. So that's the background, and I'll start with the topic. If anyone wants, you can scan this one. It's going to pull up an article which is a foundation of this topic or this talk, right? So getting into the topic, it's about how AI agents could be running your security operations center to prevent cyber attacks. People working in SOC, can you please raise your hands? Any SOC analysts? Okay, quite a few, quite a few. Okay, I see one there. Okay, yeah. So security operation centers, like burnout is a real problem. The volume of alerts that the SOC team has to handle is really huge. And we are going to talk a bit about a SOC first and then the problem. And I'll just walk through the proposed concept of a semi-autonomous security operations center, right? So, like, not assuming everyone is super familiar with security operations center, so I'll use a slide or two and spend like a minute or so explaining about SOC, the role of a cybersecurity analyst, why it is a problem, and I'll touch a bit more on generic automation, and then we'll move to the topic about AI agents and how a group of AI agents or an army of AI agents can be used in a security operations center. And I have a short example, and we'll go through some challenges. So just explaining a bit more about SOC. Yeah, so yeah, he's just 31 years old. Security Operations Center for any organization is basically a team of 24/7 analysts who will be working to protect companies' data, intellectual properties. And the way it would work is SOC would work of alerts or detections that the detection team would create. Now, breaking a bit more on an alert or an event, so it is a set of rules or set of logic which triggers based off some thresholds. For example, your company might be interested in knowing someone logging in from an unauthorized location or a different country. It can be an alert. A simple alert could be like someone failing entering passwords, a brute force attempts like 25 passwords in 5 seconds, those kind of things. So all of these are alerts, right? So now the problem is to handle these alerts, security analysts have to use multiple tool sets. So obviously there is the SIM or SOAR or any input mechanism wherever you get your alerts from. Then to handle that alerts, you need access to Active Directory sometimes, you need access to ticketing tools, you need access to the proxies, you need access to the firewall logs and those kind of things. To analyze that particular alert, sometimes you need to go through HTTP traffic, you need to know those codes, PowerShell obfuscation, you need to decode it, you need to take some actions. If it is a phishing, you need to analyze the complete URL, you need to purge those bad emails. So there is a lot of things that a SOC analyst does. And On top of that, all these things are very time sensitive. So everything is done in a very high pressured, high speed kind of an environment, right? So that is also a challenge. So um, all this manual process has to be addressed by some sort of automation, and not just cybersecurity, but every other industry in general. We see that relies on some level of automation. For example, one wants to design a website wherein they just want to pull in the best deals available about a product based on all other websites. So there is web scraping that is done. You collect that data, you put it up. All that is automated. So this is one example, simple example of an automation. Think of a more manufacturing level or a warehouse level automation. You see that boxes that needs to be shipped to New York land in there out of their whole chain. Boxes to be transferred to Chicago will go there. So this is all automation that we see in our daily life. The challenge here is these automations are really very much predefined and static, and does not have its own reasoning abilities, does not have its own mind in a way, right? And many times these are very difficult to modify or change on the fly. It needs a lot of work to change those things, right? So this is the problem with the traditional automation. So for now, in SOC, we have in a way already migrated from SIM to SOAR, right? But again, the problem about automation is the same. We need playbooks all the time. We need SOPs all the time. And if there is a gap in that playbook, it is not going to work as you want. And to fix that, it is also a challenge many times. So now moving on to the topic, or the more central part of the topic is AI agents. So AI agent, we can think of it as first, okay, anyone experimenting with AI or AI agents has deployed one, or okay, not many, but a few. Okay, awesome. So AI agents, we can think of it as lines of code or software which has ability to basically connect to an LLM, large language model, from where it can get more information and get more context. And it also has an access to the tool set of your infrastructure, wherein you grant it the access, and it can take actions on behalf of a human SOC analyst or a human analyst, right? So that is the whole idea. And it has a short-term and a long-term memory, wherein it becomes more easier for the AI agent to learn from its own past mistakes. I mean, you can rate, you can give it a feedback that this was done right, this was done wrong, and it would learn from that reinforcement learning, or that feedback, basically, right? So um, there are different features or many more than this. I'll just quickly cover one or two. We just don't want to think of any LLMs or AI agent as just a storytelling machine or a programming kind of thing. It is more beyond that, right? It has reasoning and strategizing abilities. If you give it a cybersecurity related question or a scenario that this is what is happening, how would you respond to it? It is going to give you a detailed response of what things can be done. So the whole idea here is to convert the instructions to prompts, basically, and then a playbook to a template, because LLMs or like any Gen AI, Gemini, or whatever you all must be using, it works out of prompts, right? You give it a prompt and it gives you an answer. So think of it in a way of converting a playbook to a template which is full of prompts that will be fed to the AI agent, and that's how it will take actions. So, and this is the whole crux of the thing, or the main slide about how there can be a group of AI agents or an army of AI agents work together to handle some of your security operations center work, right? So there is an alerting mechanism, and your alert input can be anything. And there will be agents. So these agents, or the main thing to note about these agents, is everything has to be really specific, because the way how human analysts work is there is a lot of different complex tasks that they do together. But in terms of AI agent, we have to think of it as we have to give each one individual specific tasks, and the power unleashes when all of them work together to take the actions, right? So an alert will come to handle the alert. There is a group of AI agents, that is the alert fetcher agents, you can call it that. Then after extracting the important information, you pass it to the investigative and the analysis agents. They perform their analysis, and then you pass it to the decision making and the response agent, and those have the access to the tool set of your environment. For example, the AI agents come across a malicious hash, you want to block it in your environment. uh, that is the work of the decision and the response agent to do that, right? And at the bottom, we have like control and coordination agents, basically, because while in SOC, many times you need to raise a different ServiceNow ticket, or any case management tool, or a IBM tool, whatever you might be using. You need to do that. You need to place a forced block on proxy for any domains or any firewalls, those kind of things. So there has to be a constant connectivity. Those servers or those mechanisms should also be up and running to enable or facilitate SOC analyst's role. So who is going to all those kind of things? So there will be a set of control and coordination agents that can take care of that. And all these agents will in a way be connected to a large language model, which is custom trained based on the context of your organization. Now, context is the key, because anyone would be able to build the automation and get things working. But like, think of it as a human analyst. So what is the speciality of a human analyst? We have the context of our organization. Something that is not normal in your organization might be very normal in my organization. The level of traffic that my organization faces might be different than yours. So humans have that context. So the real game changer here would be the custom trained LLM models based on the context of your particular infrastructure. That's where the real value would come in. So that's the concept of the semi-autonomous SOC, and it has been deployed in few companies. There are companies dedicated to creating the AI virtual SOC analysts, and it is not 100% replacement of a human analyst or the entire team, but think of it as a force multiplier of your team, who will not get burnt out, who will never be tired, who will work 24/7 with you, and with high accuracy and very high speed as well, right? Because when you are tired, it's very easy for you to uh, put 10.12.13.14 for an IP address, wherein it was .04 at the end, just for a lame example out there, right? So those mistakes can be avoided by this kind of AI SOC agents. And this is just a group of AI agents I was talking about. So these boxes, the smaller boxes inside, I have just categorized them under groups. And if you would have like scanned that QR code earlier, I have very detailed description of all the AI agents and the specific tasks that they would perform. And this is just a quick slide of agency of those AI agents. And this is as per NVIDIA, but different company would define it in a different way. So the first or level 0 is inference API. It's just like Gemini or ChatGPT, you just query and you get a response. First one is a deterministic system which will have a predefined set of rules and it will just do that. Second is a weak autonomous system wherein it will still have some predefined rules, but it will also use its own context and use some of its agency to take actions. Then is a fully autonomous system wherein it will decide to give you control back or not. It is going to take care of everything given the right access. Right, so that's about the level of agency. This is a very short example I wanted to throw in here. Now, to solve this, you don't need AI. Believe me, it can be done without AI. However, I want you all to think of it in a way that if an AI agent will do some of these tasks, how would it look or how would it go? So like as I explained earlier, it will have a alert fetcher agents. It will fetch your alert. It will extract the entities. It has to be enriched with some more information which is not already there. It has to be enriched with the context of your environment, and it will pass through the investigation agents. It will collect the evidences. It will run a scan. It now has a power of a custom LLM within it, so that it can get some more context over there, and it can also take actions if you allow it. So that's a short example for that. And definitely all of these comes with a lot of advantages and as well as a lot of challenges, right? So the agents that you would have would be limited by the custom trained LLM model you have in there. If that LLM is not trained against any similar scenario, it is not going to know how to react. If it is exposed to any unfamiliar environment, just like think of it as a someone just right out of school and working for your SOC, they are not going to know what to do. It has to be trained. Even like in organizations, we have cyber awareness training for humans who are not so much techie or like all sort of employees, right? So everyone has to be trained. So think of an AI agents or a group of AI agents in a similar way that they would have to be trained. So exposing directly to an unfamiliar environment might not be the best idea. And we all know about how AI can be targeted. Think of like prompt injection attacks or different attacks. So your AI agents can also be targets. The second last point is traceability of AI agents that I want to emphasize more on. So what I mean by traceability is that whatever actions you allow your AI agents to take, they are going to take it, but then there should be a detailed log of everything. You should be able to trace back what it did, because it happens a lot sometimes in SOC that an alert or an event or an incident you worked on 2 weeks back, uh, like something surfaced again and you want to look at it. So you need to go through the notes and you need to see what happened. So that is why traceability is really very important. And obviously the risk of granting access. So the risk would come in from not 100% from the agency you give to these AI agents, but from the unpredictability of the model's behavior about the access that you gave to it. So that is a risk I wanted to define here. And yep, that's pretty much. I see the time up banner, so open to feedback and ready to questions, ready for any questions if there are. Okay. So I don't like to think of it as cutting off what you already have and then 100% focusing on this. So it has to be a hand in hand, a parallel kind of an approach, and I mean it would definitely be an extension of what you already have. You already have a SIM or a SOAR or EDRs and detection and response capabilities. So this kind of mechanism can be an extension to that, because an alert still has to trigger from somewhere for your AI SOC agent to take care of it. So depending on like I mean, it will be best approach to first target the low-hanging fruits, identifying like you know your SOC the best, what kind of stats you have, what kind of alerts your analysts spend the most time on. Within that, what are the subtasks wherein they spend the most time and what are the pain points, and then trying to automate those first and then slowly phasing out the traditional system. So it would completely depend. So I mean, I cannot answer like a fixed time for that. Like it is going to take you 3 months or 6 months, kind of. All right, I see one there. Oh yeah, sure. So it's not a site. It's just one article, but yeah, it will help with some definitions out there. Right. Questions? Okay, one back there.
Yes. So what is the occurrence of either the weak or the fully autonomous systems taking action against false positives or not taking actions against true positives? And do you see any impacts with that?
Definitely, there are impacts. So, to answer the occurrence part, it's difficult to give any number, but think of it as a system wherein think of it as a weak autonomous system wherein once it takes some actions, you will always have a human SOC analyst or your team of analysts to rate it and review it. If it worked correctly, you just rate it as a thumbs up, for example. It is going to go through the feedback loop again, and your AI or your model is going to learn from it that whenever something similar comes, the AI agents handle it perfectly. So it is a thumbs up. If not, something has to be changed or tweaked. So that tweaking would be in the form of the prompts that you provide to like that's what I mentioned, right? Think of it as changing the instructions to prompts and like playbooks to a templates with a set of prompts. So it would definitely like it would depend on that.
Thank you.
Yep. All right, I think we are at time. Thank you so much for being patient and listening, and thank you so much to the organizers and volunteers and everyone to put up a great con. Really appreciate it. And for like-minded individuals, if anyone want to get in touch, feel free to shoot me a LinkedIn request. You can scan it here. Thank you so much.